In 2016, the SDVoE Alliance defined 4K AV over IP for the Pro AV industry. Today, we're on the cusp of even higher resolutions, and our technical wizards have been working behind the scenes to make it possible to transport 8K across a network. Recently, I sat down with Stephane Tremblay of the SDVoE Alliance to see 8K SDVoE in action. We also invited Chris Chinnock of the 8K Association to help us answer some big questions, such as what does 8K mean to Pro AV? Why is Pro AV going to care, or even if they're going to care at all? What's the use for 8K now and in the future? Join me for this sneak peek behind the scenes at SDVoE HQ.
Hi, I'm Stephane Tremblay, CTO of AptoVision division inside Semtech, and I'm here today to present you about a cool new product we're gonna release soon. It's an 8K transmitter and receiver entirely compatible SDVoE.
Hi everyone, I'm Chris Chinnock. I'm the president of Insight Media, as well as the executive director of the 8K Association. So thank you for inviting me to learn more about your great demo. I'm very excited to discuss it more.
Let's take a look at the equipment topology being used for this example. We've got a 4K media player connected via HDMI 2.0 into an SDVoE transmitter, which in turn has 4 10 gig links to a 10 gig switch. Then we have an 8K PC connected via HDMI 2.1 going into an SDVoE transmitter, again connected with 4 10 gig links. That 10 gig switch then is connected to an SDVoE receiver, which in turn is connected via HDMI 2.1 into our display. Let's head back to the SDVoE HQ.
Okay, so you're getting a nice uncompressed signal to your board. What happens in the board now? Tell me what happens specifically, how it's processed.
Okay, so let me pull back my camera to show you a zoom in of the board. So if you can see on the boards, we have 8 AVP ASICs. So these are the normal ASICs that you will find in any SDVoE product that's made today. And the reason is we can have a little FPGA, very cost-effective FPGA in front to split the signal in a by 4 fashion. So we take this 40 gigabit and the very first piece of logic that signal is going to hit is an FPGA that will then create 4 10 gigabit right out of this 40 gigabit. But no compression whatsoever. So you get pristine quality and it's done at speed. So there's no latency added to the signal. So the first FPGA will then split to 4 normal 10 gigabit going into 4 AVP. Those 4 AVP are connected to a QSFP 4 times 10 gigabit Ethernet output. But now nobody needs a 40 gigabit switch, right? Because in fact, these are 4 independent 10 gig links. So what we have here is a normal Netgear switch with 10 gig ports, and that's it. It's just that we use 4 ports instead of only 1 QSFP. But regardless, you can use 1 QSFP port or 4 normal 10 gig ports.
Okay.
And the reverse function is performed at the RX where, the 4 times 10 comes into the Ethernet port. They are sent to 4 AVP. Then the output of those 4 AVP is then sent back to 1 FPGA that combines everything back together for HDMI 2.1 signaling.
Okay. So when you split it, are you basically taking each of the lanes from HDMI that's coming in, and those, is it a clean separation along by lanes, or is it more complex than that?
It's slightly more complex than that because we want it to be compatible with the rest of the SDVoE system. So in order to be compatible, we need to fully extract all the timing information. So where is the H sync? Where is the V sync? Where's the blanking? Because as you know, we don't want to transmit any data during blanking. That would be waste of bandwidth. So because we extract the raw data out of the DSC compression and we treat it as pixels, right? But pixels with a real start of frame, end of frame, this is audio data, the audio gets separated and et cetera, et cetera. So we have to perform the full decoding still. It's not just a dumb separation per lane.
Stephane, HDMI 2.1 defines a lot of formats that could be referred to as 8K because they're 8,000 pixels wide. But there are different bit depths and different frame rates and different chromas and color spaces and so on. So which of these formats can this system transport and which, if any, can it not?
Good question, Matt. And this product is ideal to transport any type of resolution that can come in on an HDMI 2.1 port. And the reason being is that we do transport the snippet or the compressed pixel without any further compression. So no matter what's the 8K resolution that will come in on the 40 gigabit port, it's going to be transported as is without significant latency added to it.
So 40 gig is a lot of bandwidth. Why did you make that choice?
The reason why we had chosen 40 gig is also because right now all these 8K installations are really expensive and really high-end, right? Nobody is going to blink about using 4 10 gig ports out of a 10 gig switch because those ports are not even $100 per port. Once 8K become mainstream and there's lots of volume and 8K is taking the lead over 4K, of course, we will consider compressing the signal more to fit on a lower bandwidth as far as the switch is concerned. But that day didn't come yet, and it's not for years to be. And compressing the signal is also very difficult to achieve without compromising it, right? So if you choose to go 8K, that's because you want to have higher quality than the 4K that is uncompressed today. So if you are to decide to go 8K compress, well, you still need to end up having a better quality than your 4K uncompressed. So it's not true to say, okay, let's compress the signal 20:1, and we're still gonna end up with a signal quality that's higher than the uncompressed 4K. No, it doesn't work that way. So the next compression engine for those 8K resolution is going to be significantly more complex than what's available today in other Pro AV solutions.
Okay. So what applications do you see for 8K in the Pro AV space right now to drive the adoption of an SDVoE solution?
So with the experience I have with customers so far, I think the first 8K is going to be on those huge screens being used in concert hall, presentation hall, those screens that are super expensive and super big in size. This is where you need to have the resolution, because if you have a 65-inch display, might not appreciate that much the fact that it is an 8K display. But if you have a 65 feet display, then it starts getting something else, right? You need the pixels, you need the resolution, because otherwise you notice that it's lacking in terms of pixels. So there we have it. An exclusive behind-the-scenes look at how our technical wizards have been making it possible to transport 8K across a network.